Alright guys, what's going on? So today I'm going to try to get through all of domain 1. That's the goal to finish up today so that Thursday, Friday we have enough time to get through domain 2, 3, and then Monday on that makeup day we can finish up with domain 4. So I'm going to try to go a little bit faster than I did yesterday. Try not to talk too long. So we're going to get started with domain 1.2 here, which is given a scenario, analyze the organizational requirements to determine the proper infrastructure security design. So let's go ahead and jump right into it. So we're going to go over scalability, resiliency, automation, and then performance, containerization, virtualization, CDNs, and caching. Now remember, this is cybersecurity, so when we go over these different technologies, we're going to try to think of it from a security standpoint, but also we're not diving deep into how to deploy containers, how to set up a type 1 hypervisor. We're not going to show you how to deploy a CDN. We're just going to go over what it does and what it helps you accomplish. So this presentation explores the essential considerations for designing an infrastructure that meets organizational requirements. What we're talking about here is that in cybersecurity, we want highly resilient networks and infrastructures and architectures. So not only do we plan our defense in depth, our onion layer of security around protecting malicious actors, defending against malicious actors, we also want a highly resilient architecture that can scale up and down, that we can automate, that is well tuned to performance like compute, storage metrics, and has resiliency. So scalability. So scalability is let me just fixing some things. It's how we can accommodate for growth in our infrastructure. A great example of this is kind of going in again to cloud technologies versus like on-prem technologies. How well can we scale up resources to meet a certain demand? And then can we scale that back down? And then what's our cost? So planning for scalability really depends on your architecture. If we're in a cloud environment by its nature, to be able to even be called a cloud environment, needs to be highly elastic, meaning we can have horizontal and vertical scalability quickly and in an automated process. With on-prem data centers, it's kind of hard to have that scalability when we're limited to our actual hardware. So for example, imagine you buy a Cisco UCS chassis or Dell PowerEdge server, whatever the modern day server is, that bare metal server, and it has at max 128 gigs of RAM. Well, if you meet a demand in your organization that needs to go beyond that, and if you tuned and made efficient your workload on there and you still need more than 128 gigs of RAM, are you highly scalable on-prem data center? Probably not, because that means you're going to have to either add more RAM to that server, which means you're going to have to put in a maintenance window, you're going to have downtime, you're going to have a rollback plan, you're going to have all this change management process into it, or you're going to go buy a new piece of hardware. Where in the cloud, we're highly scalable, and we can automate scaling up, pooling our nodes, if we have containers, using something like Kubernetes to make it highly scalable. So when we're building architecture, if that's what we're worried about, meeting peak seasons, meeting high demands, and then scaling back down, more than likely our architecture is going to be in the cloud. And we have to consider what's going to be more cost effective. With the cloud, we have what's called an OpEx, operational expense, a pay-as-you-go model. You pay for what you use, and you don't pay for what you don't use. Where on-prem, we have something called capital expense, where if we buy that robust server, but for 10 months out of the year, we're only using 20% of its capacity, did we kind of waste money by buying that big robust server for maybe a couple weekends, like a Black Friday sale or Christmas, being our peak seasons where we need to use that full capacity? So something we have to think about when scaling out our architecture. So vertical scalability, what does this refer to? So vertical scalability refers to the ability to increase existing hardware, meaning we have a single server, a single node, and we scale that single node up, increase its storage and compute resources. Horizontal scalability is not the single node, but how do we pool together multiple nodes to create a single cluster, a single pool of compute and storage resources. So instead of a single server, we pull in multiple nodes or servers. Okay, resiliency. So just the actual vocabulary here, right? The definition. Resiliency in infrastructure design refers to the ability of a system to withstand and recover from failures. So are we building our systems to be highly resilient? Are we building in power adaptations? What we say by that is we have a data center, we have a power outage. Did we plan for that? Do we have a second power line coming in? Do we have generators? Do we have ups? If we're worried about a cloud data center region or availability zone going down, did we replicate that service, that application, that VM to a different region? Do we have high availability? Meaning maybe we have a hot standby configuration for our servers or like wireless LAN controllers, or any of our network infrastructure. As far as goals for resiliency, our goal is always minimize downtime, rapid recovery. So making sure we recover in a quick manner, and the adaptability to failures. So a couple different ways we can be resilient. High availability. So high availability refers to systems designed to remain operational for a long duration without interruptions, minimizing downtime, and ensuring continuous business operations. So as you can see here, in the cloud we have some HA clusters, I guess you would call them. But really what we're saying here is that maybe we have some storage accounts in Azure East, a storage account in Azure West, and we're replicating between the two. We're replicating those storage accounts. So whatever storage buckets we're accessing in the East, if it goes down and we have to fail over to the West, that's a high availability deployment. And on-prem data centers, we also have the ability to do this. High availability clusters. Think about like firewalls or wireless LAN controllers. You can build HA in there as well. Or maybe you have a primary and a secondary. If that primary fails, that secondary can immediately take over. We also have the ability for our on-prem data centers to also extend geographically dispersed regions using technologies like VXLAN. So we could have like E6I clusters in a data center in Phoenix, and then we have a data center in San Diego with E6I clusters, and they can be clustered together using technologies like VXLAN, which makes it seem like their layer 2 is directly connected. And then that gives us the ability, if E6I servers fail in Phoenix, we can do VM motion and actually do failover to that other data center in San Diego. So we have that ability as well in the data center. Okay, diversity. So sometimes we're worried about what's called vendor lock-in, where if we're a complete Cisco shop and we bought nothing but Catalyst 9300 series switches for all of our access layer on all of our campus networks and maybe all of our compounds. Imagine we're a huge organization. We just did a multi-million-dollar deal with Cisco to do 9300 Catalyst switches. Okay, now let's say there's a vulnerability or there's a bug in those Catalyst switches. Could that potentially take down all your access layer switches? Yes, it could, because you're vendor lock-in, right? So sometimes companies look at it like, hey, we want to buy multiple different vendors, so we have that diversity. So the advantage is if one of the vendors has a major vulnerability, one vendor doesn't. But what's the flip side? What's the disadvantage? Disadvantage could be the technical debt, hiring people that understand both vendors. So it can help with risk mitigation, but there also is the flip side of that, where maybe I'm a Cisco expert and now I'm having to manage Juniper, HP switches. It's possible, but it may not be as seamless. And maybe the technologies don't talk as well between each other, between those vendors. So there's complexity management. Okay, I told you we're going to go a little quicker here. So let's go ahead and do our check on learning. Let me actually bring this up. 1 second, guys. Okay, we're in 1.2.1. Let's go ahead and take this domain quiz. One second. Sorry, I was rushing to get this set up, so I didn't get some things I needed prepped in the background. We'll go over this quiz in just a second. Okay, question 1. An organization is planning to design its infrastructure to ensure continuous operation and minimal service interruption. Which of the following concepts is most directly associated with this objective? Okay, what are we thinking here? So redundancy, okay, continuous operation and minimal service interruption. That's going to be high availability, right? That is primary fails, we're immediately switching over to our backup. There's the explanation. Okay, question 2. In the context of infrastructure security design, what is the purpose of implementing a I had a speech impediment growing up, guys. I'm going to fuck this word up. Heterogeneous environment? Okay, it means like multi-vendor. But yeah, it's reducing the single point of failure, okay? So that is, we have HP and Cisco switches together, and if HP comes down, we still got our Cisco switches. So that is to reduce the risk of a single point of failure affecting all systems similarly. There's the explanation. Okay, question 3. Which of the following best describes an infrastructure designed to maintain operational performance during adverse conditions through duplication of critical components or functions? Now, I don't know if I actually touched on this in the slides, but I believe this one will be replication. So when it says duplication, so it's either A or B, okay? It's kind of just getting into the actual vocab of this. I'm going to go with redundancy. Yeah, because having a redundant system means having a one-to-one. Replication actually doesn't always mean that. Like if we think about replicating storage, like if it's asynchronous, for example, asynchronous replication, where let's say I have a storage area network in location A. Let me just draw this out, actually explain why. So redundancy is like having that immediate failover, okay? So that immediate failover means it's a one-to-one. If I have a domain controller in this data center, and this is in Phoenix, it's immediately can fail over to this data center like in San Diego, okay? Now with replication, sometimes, now if this said like synchronous replication, I'm gonna describe what this is. Maybe we'd have an issue here, right? Where I'd probably pick A. But with replication, let's say I have this storage account in Azure. This is in the cloud, okay? And this is in the East region. And I'm replicating it to this storage account over in the West region. Let's say this is my primary. When users save information here, if I have replication built, it's not always, okay, immediately replicated over that storage account. If it's like asynchronous replication, it may be every hour, right? Replicate, or every 6 hours replicate. So I think that redundancy is the more accurate answer here. If you did pick replication, I wouldn't be like, it wouldn't be crazy. Okay, let's move on. Question 4. Let's see here. What infrastructure design concept involves distributing system load across multiple servers or locations to enhance performance, availability, and disaster recovery? Distributing system load. Okay. Yeah, this is going to be... Yeah, vertical scaling's out, right? Because vertical scaling means just a single server. Clustering doesn't actually... This is worded kind of funny to me, because clustering, imagine... I said we'd go quick, but that's okay. Imagine we have these 4 servers here. Imagine these are bare metal servers. And I put a type 1 hypervisor in each of them. So this is ESXi1, ESXi2. If you don't know what ESXi is, it's the VMware's type 1 hypervisor. That's very popular in data centers. Well, who knows now, because ever since they got bought out by Broadcom, it sucks. But these are each individual servers, okay? And we could potentially cluster these and have it represent as a single server, right? But we still have those 4 individual hosts, but it doesn't, by its nature, distribute loads like evenly. Clustering as like an admin, let's say I want to build a VM in ESXi3, and then I want to build another one here. and then one VM here. That's not evenly distributed, right? Clustering just means taking all these hosts and using their storage and compute resources in a single, like as a single server, right? But it doesn't mean we automatically evenly distribute. So distributed allocation, that's a technique where we could do that, okay? So that's why it's not clustering, in case you were wondering why. Okay. Question 5. Which strategy should an organization implement to ensure its infrastructure can handle increased load by adding more resources, such as CPUs or memory, to existing systems? So yeah, you guys are right. B, good job. Single system, right? Or yeah, existing systems. That's gonna be vertical scaling. All right, awesome. We got 100%. I'm gonna go ahead, guys, and take a break. I just rushed into my office to get started. So let's take a 10-minute break, and then I'll probably teach for like a good 40 minutes so we can catch up on stuff. Let's take our first 10-minute break, okay? All right, let's go ahead and get started. So now we're going to finish up domain 1.2. We're going to go over automation, virtualization, containerization, and these technologies down here. So automation. So this is, again, high level overview of what automation does for our enterprises. Now this relates to on-prem, cloud, hybrid deployments. We have automation tools that allow us to do what's called infrastructure as code, and allows us to take those repetitive tasks that we may do day to day, and it frees us up from doing those manually. We have some automation tools here that I personally have used and love to use, Ansible and Terraform. You could do automation using PowerShell, Python as well. This gives us consistency and accuracy, and this does allow us to scale at speed. When we talked about like horizontal scaling in the cloud, it's not going to be you going on the cloud GUI and going click, 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 next. It's going to be script-based. Terraform's a great way to do that, especially in a multi-vendor cloud environment, where you could go deploy an EC2 instance, a VM instance, and an Azure virtual machine all in one script. That is automating a single process. This reduces the likelihood of human error and ensures that operations are performed consistently and accurate. We're not going to dive into these specific automation tools and protocols. They all have their own place, right? I wouldn't say one is better than the other. Some automation tools are more efficient depending on your architecture. Sometimes it just depends on the person doing the automation, what they're most comfortable with, okay? Auto-scaling. So auto-scaling is a little different. So there are actually built-in tools like in AWS, in Azure, they have something like virtual machine scale sets that will allow you to auto-scale, and it's not scripted. It's not a language per se. It's not Terraform, Ansible, or Python. Auto-scaling dynamically adjusts the number of computing resources based on the current demand. I haven't done this in AWS, even though that's the image up here. I have built Azure virtual machine scaling sets, though, and essentially what's cool about it is you get like a base image. Okay, so you have that base image, then you deploy a VM, and then you put in these metrics saying if this VM hits a 60% CPU threshold from this base image, go ahead and build another VM to take on that load, okay? Or to automatically scale it up. So this is based off like performance metrics. This does allow us to do some cost optimization, because even though we can scale up, guess what? We can also scale that back down. So we can hit those metrics as well, saying, hey, if that CPU stays at 60 to 70% for longer than 5 to 10 minutes, build that additional VM. Once that additional VM goes up, monitor for another hour, and once that original VM goes down to maybe 30% CPU threshold, kill that second VM. That also lets us do cost optimization in the cloud, because remember, it's a pay-as-you-go model, so you pay for what you use. We have another tool here called SOAR, Security Orchestration, Automation, and Response. This is an automated way to deal with security vulnerabilities, so kind of bringing it back to the more cybersecurity realm. SOAR combines software solutions and processes for automating the response to cyber threats. With SOAR, we build these playbooks that recognize either previously known attacks or based off like a user baseline, and we can run playbooks to go remediate that cybersecurity issue. So it lets us orchestrate workflows across many different security tools like a SIEM, EDR, a DLP solution to remediate cybersecurity threats. Now, I'm talking high level. It's like, okay, dude, so how do we actually do this? Unfortunately, in this exam, we don't dive into it. Just know that SOAR for the exam allows you to orchestrate workflows using playbooks to remediate cybersecurity threats in an automated way. It's kind of an acronym: Security Orchestration, Automation, and Response. Okay, performance. So when we're monitoring performance in our infrastructure, it's important that we have certain metrics that say, hey, if our performance hits this metric, we need to scale up. It's important that on our software engineering team that they're doing resource optimization, so that scaling is not always the solution. It may be that code needs to be optimized, and we need to be consistently monitoring this. So when we're in our SOC, our Splunk dashboards are not just for monitoring behavior deviations. They could also be monitoring performance, and maybe we want that as part of our daily routine and habits in monitoring. Okay, now getting into some more technology here. I need to flip these around. I'm going to do this right now. I want to flip these around. We talk virtualization before we talk containerization, right? It'll make more sense. Okay, so what is virtualization? So this is something we've been doing for a long time now. We started virtualizing data centers that allowed us to take a single bare metal machine and put what's called a hypervisor on that bare metal machine, and then create multiple different hosts within that single server. So in short, it allowed us to build what's called virtual machines. And we could take a single piece of hardware, which would have been one server, and allow us to take that single server and create dozens of virtual machines, 12 different servers, right? So that was virtualization in its genesis at its very base. It allowed us to optimize our resources, because good data center architecture is always one server per service. So imagine just a very basic Microsoft enterprise where we need domain controllers, we need maybe file server, DNS, and DHCP. Well, DNS part of kind of our domain controllers, but a DHCP service, that and a print server maybe. That right there, very basic things, right? You would have had to bought 5 bare metal servers to keep up with that ratio of 1-to-1. But with virtualization, it allowed us to say, hey, actually, one bare metal server can now host all of these virtual machines, and those virtual machines can then be our servers for our different services that we're offering to the enterprise, okay? That's as basic as it can get. We have 2 types of hypervisors. We have a type 1 and type 2. A type 1 is when you take that bare metal server and put a hypervisor engine or application on it, and then that hypervisor engine application is going to control the resources, compute and storage and network resources that get allocated per virtual machine. So the type 1 hypervisor, you don't have an operating system technically. You don't have a host OS. It is hardware, hypervisor, virtual machines. With type 2, you will have a host operating system. You typically see type 2 hypervisors on your desktops and laptops, not for dedicated servers, typically. So on my computer, I have VMware Fusion. That's a type 2 hypervisor that interacts with my host operating system. It's more of an application, right, built on top of my host operating system that then will control the allocation of resources, storage, compute, and network resources to the virtual machines that it will host in a type 2 hypervisor. So this image right here is type 2, because we have a host operating system, that's Windows, Linux, Mac, and then that hypervisor application. So to show you, here's a live example of a type 2 hypervisor, okay? And this one allows me, I run Fedora, which is a RHEL-based Linux machine, and where's my Kali? And I can run a Debian-based Linux machine, a Kali Linux machine, okay? Now let me get off of here so it doesn't, yeah. Okay, now before we get into containerization, so what do you notice with virtualization? Well, we still have that 1-to-1 kind of mapping when it comes to server per service. But now, this has increased our attack surface, hasn't it? Because let's say these are all Microsoft Windows Server. So now what do we have to do for each one of these OS? We have to integrate it into our patching, into our vulnerability scanning, into our updates. It's now an actual server that we have to monitor, manage, and keep secure. And maybe we have one OS here for a single application. So if you imagine we have a single server for a single service that's maybe just DHCP. It's very important, but it's not as optimized as we would like it. And it does increase our attack surface. So with containerization, we get rid of that. With containerization, here's how it's structured. We'll still have our hardware, our host operating system, and then we have a single container engine, and then that container engine will have what's our containers, and then the actual application in that containers. So what did we get rid of here? We don't need an operating system per service or per application. We just need a single container engine built off a shared kernel here, and now we can deploy hundreds of applications in our containers, okay? So this is more portable. It's more resource efficient. If one of these containers gets compromised, exploited, guess what? It's real easy to kill that container and download another one from our container repos. I have Docker up here because that was kind of the original, well, not the original, but we use Docker for containers, okay? That's the technology. That's the container engine there. I don't want to get too much deeper than that, all right? But when we deploy containers, we go get a container image from like the Docker's repo. It's all command line. It's all in the bash shell of our container engine or our host operating system. And we can just download it and it deploys within minutes. So talk about like rapid deployment times for our developers. When we give them containers, it's a lot easier and more efficient for them to deploy their applications on a container rather than the old school way of deploying a server, having the database there and doing it the old school way of virtualization. Okay, CDN, just to quickly talk about this. A content delivery network is a geographically distributed network of proxy servers and data centers that work together to provide high availability. Pretty much just takes like your front end of your website, whatever that is, and caches it globally so that if I have users in Australia, they don't need to reach all the way back here to my server in California to display our website. Now, database backend may not be totally a part of the CDN. It depends how you deploy it, but it allows you to accelerate access to your website or to your web applications, okay? Okay, caching. So caching temporarily stores copies of files, data, or requests to reduce access time. Caching can be done in like your web browser where we cache like cookies and other things that allow us to have a faster web browsing experience. Okay, let's go ahead and do our quiz. Save and exit. Let's go to these lessons here. We're at domain 1.2.2. Let's go ahead and do our quiz. Okay, question 1. I don't know why this is. Get that out of here. Which technology is primarily used to reduce server load and improve website performance by storing copies of files or web pages temporarily? What do we think, guys? Obviously, it's CDN or caching, but the fact that it's not really talking about geographically dispersed, I'm thinking it might be caching. Yeah, I think caching is more accurate here, because if it was CDN, CDN does this, but it's a network, it's distributed, there's servers. CDNs utilize servers around the globe to store copies of your website, not necessarily files or web pages in your web browser. So this more accurately describes caching. And CDN's not temporary either. Like if you deploy CDN, it's going to be there until you like no longer use that CDN service, okay? And yeah, CDN is not something that like, well, you could maybe if you work the back end of AWS or Azure. Like if you guys ever host your own website, it's usually just like a plugin. It's like a service. Like, hey, pay an extra $10 and we'll put your website in our CDN, all right, in our content delivery network. So this is going to be caching. This more accurately describes caching. Okay, question 2. In the context of cloud computing, what does bootstrap... Did we even talk about that, bootstrapping? Sorry, sometimes see when I go too quick, I'm like, I kind of miss it. What does bootstrapping refer to? So it's going to be A, okay? So bootstrapping, when I talked about those virtual machine scale sets, and I said you build that original image that then allows you to scale, that's what bootstrapping is, saying, hey, we're gonna bootstrap this original image for you to clone it in the cloud for our scaling, okay? Don't think I touched that on the slide, so my bad, but there's the explanation. We're covering now in the quiz, right? Okay, question 3. What is the primary benefit of using containerization in an organization's infrastructure? Yes, that is going to be C, to isolate applications and their dependencies into a self-contained unit for easier deployment and scalability. Yeah, one thing, let me go back here, and like you notice each container image is going to have all the bins, libs, and dependencies needed to run your application, right? That's why we download a container image. So like I can download an Nginx container image and that's already ready for me to deploy my web application code to, okay? But yes, to isolate applications and their dependencies to a self-contained unit. Question 4. How does a content delivery network enhance performance and user experience of a web application? Yes, that is going to be C. Good job, guys. by distributing web content geographically closer to users to reduce latency. Question 5. Which of the following best describes the process of automatically adjusting the number of active servers in a cloud environment based on the current load? So this is talking about scaling. And so the only really thing that would make sense here is auto scaling. So let's choose that. Yep, B. That one's kind of an easy one, right? Okay, question 6. What is the primary goal of implementing, security orchestration, automation, and response in an organizational security infrastructure? So remember what SOAR does, right? It automates the response to a potential cybersecurity incident. So that's going to be C. Yep, good job, guys. To automate the response to security incidents, and manage security workflows. Orchestration. All right, awesome. So that is domain 1.2. Now let's move on to domain 1.3. Now in domain 1.3, what are we going to go over? Let's check it out. Okay, in domain 1.3, given a scenario, integrate software applications securely into an enterprise architecture. So now this is kind of going to go over our development process. So we're going to go over baselines and templates and software assurance and the different ways we can test software before it goes into production and different tools we have. And then in the next section, we're going to go over integrating enterprise applications. So kind of define these enterprise applications if you don't know what they are, and then how to secure them. A lot of times for a lot of this, guys, is, even if it's not on the slides, a lot of this is just IAM. It's always going to be IAM and just making sure that libraries and things in the code don't have any well-known vulnerabilities, okay? Sometimes you'll have a developer and they on accidentally do like a race condition, or they're not giving memory back properly to the RAM when they deploy their application. Sometimes you get that, but a lot of times a lot of this just relies on having good IAM, and that stops a lot of the attacks. Now there is going to be other things like input validation they have to think about, but anyways, we'll get into it. Let's do it. Do I have a domain 1.3.3? Hold on. Okay, so there's going to be some heavy slides, I think. Okay, so introduction to secure software integration. So integrating software applications securely into an enterprise architecture is crucial for maintaining the CIA triad is pretty much what it says, okay? So we're going to go over security best practices, how we strategically as a business align here. So making sure we have good CI/CD pipelines that do integrate the cybersecurity team. And depending on our business and what we are, what we're doing is, do we deploy code in an agile way where it's continuous integration, continuous improvements, and just get your MVP to market? Or are we going to be more of an OT environment where before we deploy, no, it has to work 110%, more of like a waterfall type of deployment? Okay, so first, let's talk about baseline and templates. So baselines and templates provide a standardized approach for secure design and deployment of software applications, ensuring consistency and compliance. So this is kind of a way I like to describe it. I'm not a software engineer, but baselines like we do in, our system administration. Maybe we have a golden template configuration for our baseline images. That's essentially what you can do for software engineering as well. Maybe you have like a framework like, hey, you're adding a couple pages to our front end. Here's the framework. Here's what's already built into this baseline for when you deploy this new HTML page. And go ahead and make your changes. Go ahead and put the content. But here's our wireframe, right? And we kind of have that baseline maybe for the entire software engineering team. Secure design patterns or types of web technologies. So I kind of already touched on this yesterday, but we want to make sure when we're deploying web applications that we're worried about well-known vulnerabilities and minimizing our attack surface. So that is using things like web application firewalls, building security into it, worrying about data transmission, making sure we are using TLS, HTTPS. So maybe we have some HTTP enforcement headers on there like HSTS. Looking at OWASP and seeing what's the top 10 vulnerabilities and remediation for that. Okay, container APIs. So container APIs enable secure interaction with containerized applications. So this is just saying, hey, when we are kind of in this new way of deploying web applications and this microservices, it's not a old school monolithic web architecture, we have API endpoints that we want to protect, okay? We kind of already talked about this day one, so I don't want to continue. Secure coding standards. So make sure that your developers are adhering to some sort of coding standards when it comes to security. Now again, the industry you're in is going to kind of dictate how anal you are about this, right? If you're trying to get a SaaS application onto the DoD and you have to go by FedRAMP compliance, you're going to need those secure coding standards, okay? Now, if you're just deploying web application on your WordPress site, go with the best practice of how to secure a WordPress site. So you want to make sure that you're always looking at those standards. And again, if you need help finding what those standards are, a good website for that is OWASP. It's open source. We have things like MITRE, the MITRE attack framework. Let me get there we go. We can look at ways to protect your web application, okay? So you want to make sure that you're adhering to some of these standards. Unfortunately, we don't have enough time to go through those two websites, but okay. The application vetting process. So if you're integrating third-party applications or you're developing an application, before you deploy it, you want to make sure that it's going through some change management process that does involve a security review. We're going to get into the different techniques to do this, but you can have a static or dynamic analysis done on that application before you actually deploy it to production. So you want to make sure it's also in compliance. So if you're putting something into production, that's part of the finance industry. If you're going to be a data processor for credit card transactions, and you're doing something custom, make sure that it's in compliance with PCI DSS or HIPAA code if you're doing healthcare. API management. So this is just saying do not start just letting don't start opening up your API access to the whole entire world, okay? You want to have some sort of API management from your back end to your front end to your database where you do have that API gateway, you're monitoring it, making sure you have proper authentication and token use on that API, and that only your developers have access to it. Okay, software assurance. So software assurance encompasses measures to ensure software is secure, reliable, and resilient against attacks. These slides, guys, are just kind of just going over vocabulary for the exam. When you hear these terms, what should you think? So software assurance talks about the life cycle of software and how do we have Q&A? How do we make sure it's reliable? How do we make sure that we build trust with our customers when building this software? How do we make sure we prevent exploitation? Now, again, I'm going to keep saying it, but it kind of goes by your industry, right? All right, another technique we can have to give us software assurance, sandboxing and development environments. So this is just saying, hey, before we start deploying code to production, maybe we want some sort of sandbox. Maybe if we're doing some patching, we're applying patches. Maybe we want to put some network resources or a production network, emulate that in the sandbox, apply those updates, apply those patches, and see if it has any adverse effects. So just isolation of our test environments. This allows us to have risk reduction when we do sandboxing. So it allows for the safe examination of testing of code. This can allow us to have, it says rapid prototyping and testing, but yeah, if we have a one-to-one match from production into our sandbox as much as we can, it will allow us to say, hey, this worked in our sandbox, it'll work in production, now we can quickly get it out without any bugs that we know of, right? There's always going to be probably some bug when you go to production. When building applications, when building software, you're going to have to integrate third-party libraries. Do those third-party libraries have any vulnerabilities? So we want to make sure that we're assessing those third-party libraries, and if we depend on those for our application to work and they're inherently insecure, that's a conversation. What's our risk appetite for the organization? Do we just have to restart without that third-party library and find a new way to architecture it out? Do we need to have those third-party libraries as a part of our regular updates and reviews? So just making sure that when we're integrating third-party stuff into our custom application, whatever that is, make sure they're validated, okay? And this is the cybersecurity analysts, the cybersecurity engineers' role in that development lifecycle. Okay, your DevOps pipeline. So the DevOps pipeline kind of describes IT operations, DevOps, and developers working all into one to rapidly deploy code and have continuous integration in a scalable and efficient way where we're all on the same page, and here's all the tools we have to do it. When it comes to our role in that, we kind of call that DevSecOps, development, security, operations, and as a cybersecurity professional, we have our little like monitoring here where it says in this cycle, but really we're worried about all these and all the threat vectors that come into play with our pipelines. So if our DevOps team is using Docker, using Ansible, Kubernetes, Terraform to rapidly deploy, do their scripts have any third-party libraries? Are they using proper authorization and authentication? And then our developers, is our GitHub protected? Are we putting, maybe some knowledge on a public Confluence or Jira page that shouldn't be exposed to the public? How's our cloud-based resources being handled? Is there IAM? Is there API management? Are we using secure protocols when accessing the cloud and doing our API calls? So just like that, right? A little bullet down here called security as code, just saying that embed security practices into the pipeline. Find a way to insert yourself into that development pipeline in an efficient way, in a way that still allows us to protect, but not hold up production, okay? Now, again, that all depends on the industry and kind of like your risk appetite. Code signing. This is just another single technique that allows you to digitally sign executables and scripts to say, hey, I am the one, this is coming from us, this is coming from our team, I signed this here. It allows you to have non-repudiation, authenticity, and integrity for that code. So if people go clone your GitHub repo, maybe it's in a public way, it's a public GitHub repo, they know that, hey, I can check this digital signature. Okay, the different testing approaches. So I kind of talked about this. If we have a good DevSecOps pipeline where it hits the cybersecurity engineer's desk before it goes into production, how are we testing it? How are we testing our applications? So we have three things we're going to talk about here. Dynamic application security testing, static application security testing, and interactive. With dynamic, we can use things like fuzzing tools where we're actually interacting with the application. We're actually sending real-time data to the application to see what it's going to do. Did they put input validation? Is there protection against buffer overflow? What about integer overflow? That's not the term, but making sure, I don't put a negative number in there and it crashes the system. Making sure that it's not exposing too much things on its error handling. So if we send a bad URL request, it's not replying with, oh, here's your 404 error code, and here's the operating system and the version and kernel we're on. So making sure we have good error handling as well. So we're sending SQL injection attacks, cross-site scripting attacks, and dynamic application security testing. With static application security testing, this is looking at the source code, looking line by line, seeing, hey, is there inherent vulnerabilities with, and we may do this with a senior developer, senior cybersecurity engineer. So that's before we compile it and do our dynamic testing. And then interactive combines kind of both. That's where maybe we get on our IDE, so we get in like our VS Code, and we have an interactive security testing plugin. And we're like, hey, we're going to compile some code, test it. We may just review code, and we may have a tool that helps us do the review for the code. And now we have a bunch of that, right? Copilot, Cursor that helps us review code, AI-enabled security plugins. Okay, let's go ahead and do our check on learning. What are we at? Domain 1.3.1. Okay. Let's go ahead and take our domain quiz here. All right, question 1. In the context of software assurance, how does static application security testing differ from dynamic application security testing? Let me bring up the chat in case you guys are answering. So it's not A because we don't analyze source code at runtime. No, static is not, we don't want it running. So C is not correct either. Both require the application to be deployed. No. Never, right? If we're testing, we're not doing it in production. Well, hopefully. So only answer here is D. Static application security testing analyzes the application source code at compile time or in a non-running state, while dynamic application security testing analyzes the application in its running state. So yes, it is D. Good job, guys. Question 2. What is the significance of code signing in the context of software application integration? So I'm looking at A here. It verifies the origin, gives us authenticity and integrity. It doesn't encrypt it, it doesn't compress it, it doesn't translate. So yeah, A. Good job, guys. Question 3. Which technique is specifically designed to isolate untested code, changes, and minimize their impact on the existing development environment? Yeah, none of these. Containerization could fool you if you don't know what that technology is. But no, this is sandboxing. Question 4. What is the primary purpose of implementing secure coding standards within software development practices? Not that, it doesn't really affect user interfaces. Probably going to go with B here, right? To minimize security vulnerabilities by adhering to best practices in coding. It doesn't enhance speed, it doesn't reduce the cost either. It's almost like a burden sometimes on some businesses, what they believe. But yeah, it's going to be B. Question 5. Which of the following best describes the role of API management in integrating software applications securely into an enterprise architecture? It's not improving. Reducing physical storage, no. Yes, we're going to go with C. It enables secure communication between different software applications by managing and securing APIs. All right, that's 100%. I'm going to give my voice a rest, guys. I have a daytime job now, so I don't want my voice to be completely fucked, so I want to take another 10-minute break. We'll come back and we'll finish up domain 1.3. All right, guys, let's go ahead and get started again. So we're finishing up domain 1.3. Let's talk about integrating enterprise applications. So we have all these different enterprise applications that we may have to manage in our enterprise. So we're talking about here is like third-party apps. It could be SaaS applications, or maybe something we have to host on-prem that could be a big attack surface for us. So we have content management databases, content management systems, our e-commerce site, our customer relations management system, our enterprise relations program, financial applications that we may all have to manage and monitor as a SOC or as a cybersecurity engineer. Main thing, again, I want to focus on is really just the monitoring, making sure we're in compliance with whatever industry we may be in. So again, if we're like worried about HIPAA, making sure we're not exposing PHI, personal health information, into our content management system or into our customer relationship management system that may be public facing or maybe can get exploited. Making sure that we're always ensuring multi-factor authentication for any login to any of these enterprise applications. We also want to make sure that the data flows correctly. When we're integrating things into our enterprise, we want to make sure that there's a good data flow for them. What we're saying here is just making sure that there's high availability for our users and maybe establishing some sort of single sign-on for them. Integration enablers. So this is just kind of going over, okay, if I have this customer relationship management system, like we use something called HubSpot in my company, Trepid Technologies, can there be some sort of way that when I create their account on Office 365, their Entra ID account, or maybe their on-prem Active Directory account, that my salesmen, when they access the enterprise, can also access HubSpot using that account so I don't have to manage two different accounts. So what's my integration enabler there? What do I have to worry about? Well, what kind of directory services do I have, and do they integrate well into those third-party enterprise applications that we may use to run our business? So that may be something you may have to worry about. DNS. So how is that an integration enabler? Again, maybe we're developing a finance app and we have to go put different A records or C name records so we can establish like, oh, financeportal.example.com. And that's something we have to worry about with our DNS. Okay, integrating security into the development lifecycle. So whatever our development lifecycle is, the acronym here would be SDLC too. If you see it on the exam, SDLC equals software development lifecycle. How are we integrating security and where are we integrating security? It's gonna keep, I know I keep saying it, but essentially a lot of this is gonna be determined on our regulatory requirements and also the risk appetite of the organization. So it's important that we insert ourselves into that lifecycle to stop vulnerabilities before they get to production, but we want to make sure that we're doing it in accordance with what our stakeholders want and our regulatory compliance. So defining security requirements early in the development lifecycle. So now let's imagine we're like an MSSP, so a managed security service provider, and we get hired on to make sure that web applications or enterprises is secure for one of our customers. Well, it may be good that if we have a sit down, kind of like the same way a penetration tester would do with their ROEs, like the rules of engagement, and make sure we align with that client to say, hey, I want to go over exactly what you want, how we're going to help you protect, what compliance you're worried about, what audits you may be worried about, and make sure we're aligning with your stakeholders. And this is just a little example of like a very, very basic rudimentary Excel sheet of let's go over the assets they have. Let's make an assessment. They have a login page. Let's go over their business need. It was requested by their CISO that we come in and make sure that it's secure. What department is building that login page? DevOps, so that's who we're gonna have to maybe directly interface with. And what kind of security tests are we gonna do? And we're gonna write this down in some rudimentary, Excel sheet, some spreadsheet, whatever system we may have, and then present that to the customer and say, here's everything we're gonna do, everything we're gonna go over. And let's establish this first before we start getting into the protections we're going to offer you, okay? Just an example. Fielding securely. So fielding involves the deployment of software into a production environment and ensuring that it is securely configured, installed, and maintained. So this is just saying, hey, how do we as a cybersecurity professional, we deploy an application to production, how do we maintain and monitor after that? What's our operational security? What are we doing to make sure that it's updated, patched, maintained? How are we logging accurately? Are we introducing a SIEM into that? Are we using Splunk? And then how are we doing education for the users to be aware of any maybe security vulnerabilities that they need to be aware of, or the necessary training on this new system? Insertions and upgrades. So the process of insertion and upgrades involves securely integrating new features, patches, or updates into existing software systems. So they're just saying, hey, when you're upgrading, when you're inserting something into an already working production network, make sure you're doing it in a secure way. What does that mean? From my experience, this means that when we're doing Patch Tuesday from Microsoft, I'm not just deploying those patches right away, because I may have third-party applications that weren't developed with this new upgrade. It may be a major or minor upgrade. So what I'm doing is I'm applying patches in a sandbox environment, seeing how it affects in that sandbox. Is there compatibility issues? Are we testing properly? And then I'm bringing it to the change management review board, whatever that is. If it's with software, that may just be a pull request. If it's to something that affects production in a larger scale, like, I don't know, patching a firewall, right? That could bring down the entire network if it messes up the operating system of that firewall, making sure we're getting that reviewed first, okay? Just making sure we're doing the proper steps. Disposal and reuse. So when we deploy a web application, if it's dealing with sensitive information, PII, PHI, are we planning for the disposal or reuse of that data? So if we aren't, what are we going to do when that time comes and we got to upgrade the database and maybe delete or destruct something? So do we have secure decommissioning? How are we doing data sanitization? Is it meeting some sort of compliance within our industry? Reuse considerations. Evaluate the security implications when repurposing software or hardware. And then, of course, testing. So how are we testing in our development lifecycle? So this should involve the systematic identification or remediation of vulnerabilities and defects in software applications. So a whole lot of words to say, hey, when we're testing, we're making those upgrades, we want to be aware that we don't have like a regression error where between a major and minor version, we do an update and it actually regressed to the vulnerability that we may have fixed in an earlier version update. How are we automating this? Are we using tools to test? Are we doing A/B testing with our software deployments? And are we just making sure we're doing things in a secure and orderly fashion, okay? Talking about the development approaches I kind of talked about earlier before we went on break, we have things like Agile and waterfall testing, where Agile is pretty much create your MVP, your minimum viable product, and get it out to the consumer. And let our consumer kind of be our feedback. We get that feedback, we implement the changes from that feedback, and then deploy it again. Now, as a security professional, when we have kind of an agile deployment process in an organization, it's kind of hard to tell them, hey, before you keep deploying and integrating and doing whatever, let us do security reviews. So you got to make sure that you're taking steps to, hey, we want to integrate security into your agile frameworks. Tell us where we can fit into your development lifecycle, okay? With waterfall, we do have like a certain place saying, hey, we're going to send out an update. We're going to deploy this software. It has to pass security first before we move on to anything else. That's how waterfall works. Instead of this circle of deploy, feedback, fix, deploy, bug, feedback, fix, deploy, it's no. We're going to make sure that we go through rounds of testing so we don't need that feedback to, launch this application. A lot of times waterfall is going to be in more critical systems. So like OT environments, we're in IT environments where maybe we're selling, it's e-commerce, we have products, services we're selling. It's going to be more of like an agile framework. Okay, then best practices when it comes to like web applications. I kind of already went over this. OWASP guidelines. Follow the best practices that are already out there for you. Making sure you're using secure HTTP headers. So implement secure HTTP headers to protect against common web vulnerabilities. Then, of course, continuous learning. Make sure you're staying up to date with the new vulnerabilities that may come out. Okay, hey guys, I'm actually going to skip the quizzes because I want to get through domain 1. So you guys can just do that like on your own time if you want to do those quizzes. I know they're good check on learnings, but I just want to make sure we get through all this today, domain 1. So we're going to move on. We're going to go on to domain 1.4. And domain 1 is our most, like, it has the most shit. So that's why it's taking a little bit. Okay, so domain 1.4. This is going to be given a scenario, implement data security techniques for securing enterprise architecture. So here's the objectives we're going to go over. We're going to go over DLP, data loss detection, classification, authentication, in this slide deck. Okay, so DLP, data loss prevention. This is either a strategy or an actual technical control that'll stop data exfiltration. We have, in the CASP exam, it kind of goes over even deeper, where data loss prevention is more than just monitoring the network. Oh, they're exfiltrating Social Security. It could also be like external media and print blocking, preventing like the snipping tool or screenshots, preventing, like if we have remote desktop, preventing clipboard controls, or maybe we could exfiltrate using remote desktop, restricted VDI and data classification. So when we implement a virtual desktop infrastructure, we have strict access controls so that we can't exfiltrate from that virtual desktop that, you know, maybe to something like personal, like a personal laptop. Data loss detection. So data loss detection involves identifying unauthorized attempts to access, modify, or transfer sensitive information. So this is like doing watermarking. This is doing digital rights management, where we control access to our digital content. This is also just straight up like IDS and network monitoring, where we're just detecting what's leaving our network. You know, it's not preventing like DLP, it's just data loss detection. So here's a way we can do it on the network, right? Using something like NetFlow. Data classification. So to properly do like DLP and data loss detection, we have to know what we should be looking out for, right? So that's where data classification, labeling, and tagging comes into play. So data classification, labeling, and tagging are foundational elements of data security, enabling organizations to categorize information based on sensitivity, you know, different security levels. So different ways we can do data classification. We have metadata and attributes, utilizing metadata and attributes to classify and manage data. Okay, let's go over authentication now. So authentication techniques. We have 3 we're going to go over: tokenization, scrubbing, and masking. These are all different ways to protect sensitive information without actually doing like just full-on encryption, like plain text to ciphertext. This will alter its appearance, the structure, making it difficult for unauthorized users to understand or use the data. So tokenization, this is going to replace sensitive data with non-sensitive substitutes. With scrubbing, this is going to cleanse data sets by removing or anonymizing sensitive information. And then we have masking, which temporarily hides parts of the data, allowing authorized users to work with it without accessing sensitive details directly. Okay, moving on. Let's go on to domain 1.4.2 now. So now kind of breaking this down a little bit further, let's go over anonymization. So anonymization involves removing or altering personal identifiers from data sets, ensuring that individuals cannot be readily identified. So part of our like authentication techniques, right? When we do anonymization, we're doing privacy protection. This may be a compliance for us as well. Maybe we can't like directly encrypt our databases, so we do anonymization techniques instead, so that if there is data exfiltration and we do get exploited, that we still have some sort of protection measures. Encrypted versus unencrypted data. Really this slide, you know, this is part of the actual CASP exam objectives. So what it's trying to tell you is that when we have data in transit, data at rest, or even data at use, encrypt it. Encrypt it anytime we can, anytime it's feasible. And, you know, client to web server architecture is already encrypted. That's what PKI and TLS does for us. But we just want to be making sure that when we can, we're encrypting our data. And encryption will take our plain text into ciphertext. Now, we're not going to deep dive in the differences between symmetric, asymmetric encryption because, you know, it's not really what the CASP exam is for. But later on in our slide decks, we will kind of touch on a little bit deeper encryption methods and different algorithms. So now we're going to go over a data lifecycle as it's described by the CompTIA SecurityX or CASP exam, okay? So in this data lifecycle, there are 6 steps that CompTIA categorizes. It's create, store, use, share, archive, and destroy. So these first 2, create and storage, are kind of like before we push things into production. So we create the data, whatever that is. Really, we're talking about creating the application, right? And then when we create that application, now we have users interacting with it, maybe employees, and they're creating data. They're creating data that we're going to have to store. Maybe that's sensitive data. So then that leads us to do the storage phase. So when we're storing that data for our web application, our enterprise applications, whatever it is, do we have redundancy on it? Are we doing backups? Do we have integrity? Do we have a last known good state of it? And then how, are we preparing for replication of that data? What's our recovery plans? And then we're looking at how that data is used. So how do end users use our data? So if we're they're putting credit card information and PII into our systems, there's going to be some compliance we're going to have to worry about. What access are we giving our users? Okay? And then share. So when our data is being shared, how are we protecting it? Are we implementing controls to do principle of least privilege? DLP controls to make sure it doesn't get exfiltrated to a malicious actor. So pretty much, how is it shared and who is it shared with? What protocols are we using? We're using SMB. Well, that's something that's not secure when that port is external. And then we get into archiving and destroying data. So now when data isn't being used, do we have some sort of system where it says, hey, this data hasn't been touched in 90 days. I want to move it to an archive state. And then how is that archive storage being built? Is it isolated? Is it segmented? Is there encryption on it? And then let's say our data is no longer needed at all, not even in an archive state. We need to destroy it. Maybe it's reached its data retention policy. Maybe we put 10 years on that data retention policy. How do we destroy it? What guidelines? Is there compliance regulations we have to be worried about? If it's down to hardware like solid state drives, we can't degauss. We may have to shred or pulverize that. So that's the data lifecycle as CompTIA describes it. Do we know where our data lives? That's where data inventory and mapping comes into play. So are we documenting where our data lives, where we have SQL, non-SQL databases? What kind of data is in there? What's the flow of that data? What circuits does it transit? Are we encrypting it when it's data in transit? Are we doing proper inventory? So do we have some sort of content management system that's central for all of our, IT teams and tech teams to look at and say, oh, this is here, this data is here. That's data inventorying and mapping. Data integrity management. So we have tools like FIM that allow us to say, hey, we may have sensitive files that only certain users with certain permissions need to access. So we want to make sure that we're monitoring that. So we could implement something like FIM. So that's file integrity monitoring, which will notify admins when files or data has been changed or been downloaded or uploaded without the proper authorization. Okay, data storage, backup, and recovery. So do we have redundant data storage? So we could, think about on-prem. Are we using RAID properly? Do we have the right RAID for what our risk management or our risk appetite may be for data redundancy? Are we doing regular backups? What kind of backups are we doing? Are we doing full backups, incremental backups, differential backups? And how does it meet, again, our risk appetite? Do we have disaster recovery planning? Do we have a disaster recovery plan ready in case we go dark on our storage or wherever our data lives? To kind of touch on RAID, again, this is CASP. We're not going to dive deep into this, but we're just going to go over quickly the different RAID modes. So RAID 0 is striping, where we can quickly read and write data across our drives, but it doesn't give us any fault tolerance. So we have no redundancy in RAID 0. So maybe that doesn't fit our risk appetite, where we want to spend more to increase our storage and then do something like RAID 1 where we mirror, where all data is copied exactly to another drive. So we have that fault tolerance, where one of our drives fails, the redundant run can take over. That's RAID 1. But with that, we increase our read and write, decrease the speeds, right? of when we read and write. And then we have to increase our storage by double. Because with RAID 0, let's say these two disks are 1 terabyte each. You know, this is a terabyte, this is a terabyte. What's our full storage? That's 2 terabytes because we have no redundancy. But we take the same concept and use that with RAID 1, we still just have 1 terabyte of storage. So that's a disadvantage there, but we are fault tolerant. And then we have RAID 5 and RAID 6, so kind of like, I wouldn't say combines RAID 1 and 0, because that's RAID 10, but it gets rid of those advantages and disadvantages. With RAID 5 and RAID 6, we still stripe, so we still have those fast read and write speeds, but we have something called these parity bits. And what these parity bits do is this allows us to have a single drive for fault tolerance, because those parity bits can rebuild what was ever lost in that failed hard drive. But with those parity bits, if we have 2 drive failures, you just have failure now. With RAID 6, we have striping with double parity, where we're using these drives for double parity bits, so then we have complete fault tolerance there, or really just 2 drive failures of fault tolerance. So you may say, well, why not just do mirroring? Well, again, because it's striping, so it's still a little bit faster with its read and write speeds. Then we have RAID 10, which literally combines RAID 1 and RAID 0, and we get kind of the best of both worlds there with mirroring and striping. Okay, let's go ahead again and move on. We're not going to do our check on learning there. Ooh, this is a large slide deck. Okay. Let's go ahead and get this started. We'll take our next break at 7 o'clock, guys. Okay, so domain 1.5 now. So domain 1.5, given a scenario, analyze the security requirements and objectives to provide the appropriate authentication and authorization tools. So let's do it. So we're going to go over credential management, different password policies, and federation. Kind of break down federation a little more. And then on our next slide deck, we'll go over access control, the different protocols. And then also we'll touch on MFA and single sign-on. So a lot to go over. Like I said, domain 1's heavy. Okay, credential management. So credential management involves the processes and technologies for storing, managing, and verifying user credentials. So how do we store user credentials? Is it certificates? Is it passwords that we have to store? We have these different ways of doing that. So a password repository application. This is a software tool designed to securely store and manage users' passwords. We have end user password storage. So this is how the actual end user stores it, and if they're storing it properly, and do we have the right training for them. We have on-prem versus cloud repositories. So are we using a password repository tool that maybe sits on a local server, or is it cloud-based? We have hardware key managers. So this could be a physical device used to securely manage digital keys. This used to be like RSA tokens. We ever seen like net or system engineers carrying that around? We also have privileged access management. So this is systems and practices that manage and monitor access to critical systems. So PAM, I kind of talked about it before. This is where we can have like all of our admins use a single account, and we monitor that single account. So we don't have this privileged key creep and all these different admin accounts to manage. Okay, so overall, let's just go over what credential management does for us. It gives us that systematic way, that hierarchy to, kind of manage our digital identities, passwords, tokens, credentials. So it's essential for security, can improve efficiency, and reduce our risk when we have some sort of credential management in place. The example of bad credential management is when we just have different username and passwords for all of our network and enterprise resources, and that leaves us open for vulnerabilities, right? Okay, different password repository applications. So an advantage of this, it's centralized security. So if we do have a centralized password repository, we have a single username and password and hopefully multi-factor authentication to access it, and then that gives us all of our passwords. Disadvantage, what happens when an attacker gets it, right? Obviously then there goes all your passwords. So it helps us, it's an advantage for us, it helps us give that centralized control of managing all the passwords we may have in an individual, right? This may help us, but if it ever gets exploited, there goes all your passwords. We have end user password storage. So this involves methods and practices that individual users can employ to securely store their passwords. So this is something you can personally do. Up on the screen, I have something called KeyPass, which can be an online or offline way to store passwords. So kind of defining on-prem versus cloud. So when it's on-prem, you have complete responsibility, right, for how you manage your password repository in whatever way you want to, right? It may be central for you. But with the cloud, that's going to be stored in a cloud database. So with that, we have a different responsibility matrix. Well, now we're kind of relying on the cloud to maintain that. And if the cloud ever gets exploited, there's really nothing we can do about that, right? This also goes into, again, the cost, which is something we worry about as cybersecurity engineers. It's actually like a whole, I wouldn't say job, but it's like financial operations in the cloud, right? Something we have to worry about as well. What's the cost efficiency versus hosting an on-prem password management repository versus doing it in the cloud? Okay, hardware key manager. So a hardware key manager is a physical device or system that securely manages cryptographic keys. So this could be like a whole separate appliance, right? That can manage encryption keys. Or it could be like a little add-on here. You see this is kind of looks like it's getting plugged into a server or being plugged into a motherboard. What this does for us is this enhances our security. So putting keys on like its own hardware appliance kind of keeps it separate from the operating system, which gets exploited much more than probably a hardware key manager would. It also helps us with the lifecycle management as well. Defining PAM a little bit more. So privileged access management refers to the process and technologies used to control and monitor access to organizations' critical systems. So you can see here, Bob the admin signs into his laptop, and then he's going to sign into a shared admin account to configure a database and a network switch. And that shared admin account is exactly what it says. It's shared between different users, and it allows us to monitor that single account, but also lets us see, okay, well, we still have that accounting and auditing capability to say Bob was signed into it at the time they made this firewall change. So this helps us enforce that principle of least privilege. It helps us with our session monitoring and prevents that privilege creep of all these different admin accounts sprouting up. Kind of lets us have better control. Password policies. These are the password policies we discussed in the CompTIA Advanced Security Practitioner. Okay, we know that these kind of change. NIST puts out different password policy standards all the time. But really, this is just kind of saying that in an enterprise, have one. Have some sort of password policy created, whether that's rotating it every 60 to 90 days, how many special characters you have. Go by what the best practice is currently. Or if your organization doesn't care, they're like, no, make it easy for our users, then okay, have an easy password policy. But then on the back end, let them know this is presenting a risk. So maybe we need to invest in some multi-factor authentication, okay? Complexity. So we want to make sure we have some complexity in our passwords if we're going by, whatever the best practice is at the time. Okay, so password length, just kind of showing you the longer the password, technically the secure it is, less compromised it is. Character classes. So this is pretty much like, replacing, or not replacing, excuse me, just adding randomized characters to your password, which may be like a phrase, okay? So this reduces the likelihood of like brute force success. You can educate your user and say, hey, when you're creating this password, here's how you should probably like set it up if you're going to use special characters. So it's an involved process, right, with a password policy that comes with training, that comes with you configuring it on the back end, Microsoft Intune or Active Directory. Password history, making sure that you have some password reuse policies, that they can't keep reusing the password, or maybe you have to wait a year to use an old password. Maximum/minimum age. So this is just another password policy you could enforce that says, hey, we have to rotate our passwords every 30 to 60 days. So this ensures regular updates. Because also you could do minimum, which says, no, you can't change your password. You have to wait 15 days. I don't recommend that, right? It's going to mess a lot of users up because what if you forget it, you have to change it, right? But there should be a good balance here between security and convenience. And again, you're kind of taking, orders from the stakeholders of what they prefer, security over convenience or convenience over security. And then auditing, Make sure you're auditing passwords, making sure that people are adhering to it. Now, this is kind of automated, right? Like when you go put in those password policies, they kind of have to adhere to it. But maybe you are in a system where you need to do some audits, right? Where you're like, hey, is our password policy still up to date by the NIST standards? Okay, this is a good place to stop. Let's go ahead and take another 10-minute break. I need to rest my voice, and then we'll jump into federation. Let me put 10 minutes up on the timer. All right, I'll see you guys in 10 minutes.